Welcome to the Veritas Forum, engaging university students and faculty in discussions about life's hardest questions and the relevance of Jesus Christ to all of life.
Great, so thank you very much to all of you for coming. I was just telling Ed that I was incredibly impressed when the Who's went out about Feynman. Apparently everybody knows who Feynman is, and so I know I've come to the right place. And so it's a great pleasure for me as well to be here with Max, who's somebody whom I've always admired. We met a few times and I've read a lot of his work, and I haven't seen him on Nova, but I'm sure he's fantastic. And I think one of the things we're looking at today are really the big questions, and those are the kinds of questions that you often come to university to think about. Big questions of why are we here, what's the universe like, and how do things work, and what is it all about? And I sometimes fear that the academic system kind of pounds that out of you, right? You sit there and you have to keep regurgitating what we teach you, and really what university is about asking the really big questions. In fact, sometimes I feel that it gets knocked out of us faculty members as well. We spend all the time writing grants and doing all kinds of admin and things, and after a while you become an automaton. And one of the things I've really admired about Max is his ability to write about the big questions and think about them. And it's something I've always been interested in, wanted to think about myself, is why I went into academia. So that's why we're here today. And there's a funny kind of way that when we talk about science and religion, there's a feeling that somehow this is not really in its place in the academy. And I think that's wrong. The questions of science and religion are really important for all of us. At the very least, they are a proxy for this really important question, which is, how do I achieve reliable knowledge about the world? How do I know that something is true? How do I know that something is false? How do I know that it's reliable or unreliable? Those are terribly important questions. And coming here to the US, I mean, it's a kind of funny country where your politicians do a lot of speaking about religion, and not always that helpfully. And so I'm really happy that this is the kind of thing that, I'm not saying that I'm going to do anything more helpful today, but I do think this is the kind of thing that should be discussed openly and thought about in the university. So the first question I was asked to breach today was, what are the kinds of scientific things that I think are beautiful and elegant? And over the last few years, I've been really interested in what makes us human, what makes life living, what's the difference between inanimate and animate matter? And there are all kinds of fascinating things if you think about the natural world. One of the things that you may know, but I found very fascinating, is how many genes we share with other organisms. So we share something like 15% of our genes with E. coli, 25% with yeast, 50% with flies, 70% with frogs. If you kiss one and it becomes a prince, then it's 100%, or at least, and 98% with chimpanzees. I actually grew up in Gabon in Central Africa. My parents were biologists. We had a lot of animals at home, including Bertje, a chimpanzee that I grew up with. And just to be absolutely clear, for those of you that can't, this is me, and that is a chimpanzee. Okay. My mother says that although we look different, we behave remarkably similarly. So the question really is, what makes us different? And one of the things that makes us different is actually not the number of genes that we have, but the way that they're connected. So one of the things I look at, you see there in that corner of the graph, is each of these is a gene, and each of those connections they're like switches. You might be under the misapprehension that genes are like blueprints, like architectural drawings, but that couldn't be further from the truth. They're much more like networks of switches, like chips. And so you can rewire them and get completely different behavior out of them. And of course, what's fun about this, if you're a physicist, is that the way that you can model these is with differential equations. And so off we go and we crank, and we're very happy for a long time. And so this is one of the things that I'm interested in. What makes biological complexity emerge from this set of interactions? Is there something that emerges from there that's different from just the underlying things? Another thing I'm very interested in my lab is that you see on this picture. This is a bacterium. Bacteria swim, and many of them swim with this little motor. This is a model from KG Numba's group of how the bacterial flagellar motor assembles. This is an incredible little piece of nanomachinery. It can spin at 100,000 RPM. It can stop in something like a quarter of a turn. If you saw something like this, and I could hold it in my hand, I'd assume it was made somewhere in a factory. Some very complex system put it together. But these things make themselves. These proteins just float around, and they somehow know exactly where to go. You may not know this, but you have 10 times as many bacteria in your body as you have cells in your body. Okay? Before you all rush off to the hospital, that's perfectly normal. They're a lot smaller than your cells. Your gut is full of them. In fact, you are part human, part microbe. We talk about the microbiome. You're part microbe. And so this is a very interesting thing to think about. So while I'm speaking to you today, this process that you see here will be happening millions of times in your body during this talk. And so I actually saw this movie a number of years ago, and I thought to myself, wait, how does that work? How do those particles know where to go? Clearly, nature does it all the time, but that is an absolutely staggering feat. And one of the great things about being an academic is I could then start thinking about it. And I won't lie with my own won't lie about my own superficiality. I actually got into this field because I saw a movie, and I thought, how does that work? And this is the movie that I saw. And so I'm interested in this question: how do you make things that make themselves? And also, how do you evolve things that self-assemble to make themselves? That's a really interesting and fascinating question. It's the kind of thing that I work on today. I spoke at the physics department about how these things evolve, and I want to show you a little bit more about how these things self-assemble. I sometimes tell people that what it's a bit like is like taking Lego blocks. And if I could figure out how this works, I could take Lego blocks, put them in a box, shake the box, all right, and out would come a fully formed train. In fact, as a Christian, I think that this is how God probably made the world. Did God create the world all at once? Or did he make the world through something which makes itself? Surely the latter is a much more beautiful, much more elegant, much more interesting way of thinking about the way creation is. So that's kind of a fun thing to think about. And the main thing to get away from this is that science is fun. Okay? Science is fun. It's amazing that I get paid money to think about these things. A few generations ago, I would have had to be independently wealthy to do this. But here, me, a boy from very humble Dutch Gabonese background, can sit here and get paid money. And it's people's tax money, not yours, but other people's tax money. Your tax money will probably fund Max at some point. It gets paid, and it's great. And the reason for that is because we've found that many of the best discoveries come from this thinking about what we think is interesting. So science is very fun. I realize here I'm in an MIT audience, and so many of you probably are from science. And I'll tell you a few other tips about science that are helpful. So I do a lot of flying. I'm often on a plane. I just want to be quiet, either read or sleep. And you know how you have somebody next to you who starts asking you all kinds of questions, like, what do you do? Generally, if I say they say, what do you do? I say, I'm a theoretical physicist. That more or less kills the conversation. Exactly, that's true, it's true, right? And if that doesn't, they keep talking to me, I say, I like equations. What's your favorite equation? And so, this is probably a stereotype that we put in. I'll skip this little joke. I've solved this one, actually, happily. But it took a lot of calculation. So let me tell you something else about equations that really struck me a lot as a young student. So I have a confession to make, which was when I was in secondary school and high school here, I was interested in the usual things: girls, football. So we have football, which is a real football, the one where you kick. Not the one that you hold in your hand. I don't know why it's called a football. I think Max will feel the same, right? The real football. I was into those things, but I also was interested in quantum mechanics, and I taught myself quantum mechanics in high school, and I realized I can admit that here because I'm probably certainly not the only one in the room. But then when I went to university and I started studying, I took a course, and this was one of the most beautiful things that I've ever seen. This is Paul Dirac, one of my great heroes, a mathematical physicist in Cambridge, who in the late 1920s was thinking about the following. So I'm sure you're familiar here with the Schrödinger equation. This is MIT. Schrödinger equation, the theory of very small things. And that had been worked out in 1926 by Erwin Schrödinger. And so Dirac was asking himself a very simple question: what if I combine the Schrödinger equation, which works for very small things, with Einstein's special relativity from 1905, very fast things? Very simple question. Take an electron. What happens when it moves close to the speed of light? Will it transform according? Will it be Lorentz? Can you write down a Lorentz invariant version of the Schrödinger equation? And what I learned in that course is something really fascinating, which is that if I try to write down a version of the Schrödinger equation that transforms according to the laws of special relativity, the only way that it works is if I need a certain kind of non-commuting algebra that only works if I have not just two components for spin up and spin down, but another component, some other object. And Dirac, in his great genius, said, well, this is what the math says, and wrote down this equation. And a few years later, the positrons, the antimatter, was discovered. And I remember, as a student, doing this derivation and thinking, that is too amazing to be true. How could the mathematical structure of two very disparate theories, when they combine together, generate something even more fantastical like antimatter? How could that demand that kind of obedience, if you wish, from the physical world? And I think these are some of the most beautiful things that there are in our world. Mountains are beautiful, sea is beautiful, but this is extraordinarily exquisite and extraordinarily beautiful. And I just want to tell you about that because that's something that I think is very fascinating about our world, which is what we call, Eugene Wigner, a famous Nobel Prize winner, called the unreasonable effectiveness of mathematics, a wonderful gift which we neither understand nor deserve. And so one of the really interesting questions when we look at the physical world is, why do we see this incredible, elegant beauty underlying it? And why can we, human beings, understand anything about that beauty? It's just one of the most striking things that there is in the world. By the way, on this Dirac equation, I was sure Dirac was wrong. I was sure that that couldn't be true. I spent the whole night once trying to figure out where he'd missed something. It's a typical hubris of youth. I had to bow to the great master. And I now, over time, I realize even how great he really was compared to someone like me. But this is one of the most beautiful things in the world. And a question for all of us is, what does this mean? Does this have any meaning? Why is the world this way? Why is the world so beautiful? In fact, I often give this quote to my students from Henri Poincaré. A scientist does not study nature because it is useful. He studies it because he delights in it. And he delights in it because it is beautiful. If nature were not beautiful, it would not be worth knowing. And if nature were not worth knowing, life would not be worth living. You can see that Poincaré was a Frenchman. So there is something really exquisitely beautiful about the natural world and about the way we're able to understand it. And so this is something which has always inspired me, and I'm trying to apply these ideas, these mathematical ideas, to the living world and seeing whether I can make any progress. And that, I think, is a really worthwhile thing to devote one's life to. So my brief from the Veritas team was to give an introduction to my work, and then give a brief explanation where I think these laws of nature come from, and then on a third point to discuss how these physical laws may make me think about ethics or behavior. So I'm going to talk now about this kind of brief explanation of where those laws come from and my worldview and why I believe it. I mean, these are a lot of things to cover in 15, 20 minutes, so I will be skating over them. I think one really important thing about science is that science allows an enormous worldview plurality. So the scientists in my lab, my PhD students, have a wide range of kind of metaphysical views about the world. And as long as they hold basically to things like uniformity, the world is more or less the same everywhere, it's regular, there's not miracles when your equation doesn't converge, and intelligibility, I can understand something about the world, then they're welcome to be in my lab. And that's one of the great things about science. It's enormously democratizing of all kinds of views we have about who we are and how we should live. And what's interesting is that some of these basic, what might be interesting from a Christian's point of view is not that we agree on these general laws, but the kind of meta question: where do these principles come from? Why is nature regular? Why does it follow regular laws? Why can we understand them? And we're so used to these ideas today that we don't realize that they weren't actually that obvious to most people through most time. And the reason for that is that if you just live in the natural world, it doesn't seem to be always that regular. It seems to be capricious. It changes itself all the time. And so what you can show, I think quite decisively historically, is that these ideas, these metaphysical underpinnings of science, uniformity, regularity, intelligibility, have deep theological roots. Their roots go back to a long history of theological reflection on a God who is faithful and sustains the world, therefore, in a regular way. And if you like this kind of thing, there's a lot of literature on this. There's a book that I recommend by James Hanan that looks at the It's how the Christian Middle Ages launched the scientific revolution. So one thing as a Christian, I think there's a very natural explanation for why we can do science. That's because if God sustains the world, and God is a God of order and a God of faithfulness, then I expect the world to follow regular laws. Some people would call this the customs of the Creator. So what I'm doing in my lab is studying the customs of the Creator, the regular ways that God sustains the world. So I think that within Christianity there is, both historically and basically exegetically, a very strong kind of argument for why science would work and why we should do science. It fits very naturally into that worldview. But it can fit into other worldviews, and that's one of the great things about doing science. We can ask a bigger question about our kind of worldview and what does science tell us about that. But perhaps I want to do a little side question first and just say, what if I wanted to ask you, why is there something? In other words, why is there something rather than nothing? Well, there are, to first order, roughly three possibilities. Something, like our natural laws, the laws of nature, has always existed. So there's always been something. And then you can ask, well, what caused the current universe? Well, it was something before that one. And what caused the current laws of nature? Well, it was something before that. But that quickly becomes kind of something, and what caused that? What something else caused it? As long as you're working in this kind of paradigm of natural laws, then you end up with an infinite regress of causes in some way or the other. That means perhaps another option is possible. That would be the option that the laws of nature, not our universe, but the actual laws of nature themselves, popped into being out of real ontological nothingness. So there really was nothing, as opposed to nothing, not a quantum vacuum fluctuating, but nothing. And out of it popped the laws of nature. That, too, is very different from anything that we would normally think about in our scientific world. It's something outside of the categories that we are used to. A third option would be the one of traditional theology, which would say the whole of space-time is dependent on a non-spatio-temporal reality, a being who cannot exist, who's normally called God. And so by the principle that the explanation of something can't lie in the thing that is being explained, to me this seems the most natural explanation for why there is something rather than nothing. And I think to myself, I just look around at the world, the incredible rich fecundity of the world, the beauty of the world, and it seems very hard for me to believe that that could simply have popped into being out of ontological nothingness or just be something of an infinite regress of causes. It seems to make a lot more sense that this would, by the principal explanation, come from a being who cannot not exist, something who is outside of space and time. So that is a very brief argument to where I think those laws come from. And the last thing I was going to look at is how do those sources of physical laws, how do they help me with ethical choices? So this is where I think science doesn't help me that much. And I think it's a mistake, and actually a dangerous mistake, to think that science can ground our ethics. Science can help us making ethical decisions, but it can't ground them in any way. And so I'll give you one trivial example. What if I wanted to measure the value of a human life? That's a tremendously important question, very important question, for all kinds of practical ways that we govern ourselves and that we live. Well, I'll be a bit facetious. How would I measure the value of a human life? Well, if I was a chemist, I could measure the value of the elements, but surely somebody with gold fillings isn't worth more than somebody without them. If I was a physiologist, I could measure the size of your brain, a psychologist, how smart you are, an anthropologist, how the community values you, an economist, how much economic value you produce, homo economicus. I sometimes feel like I'm measured that way by my superiors. But we all recognize that those are the wrong axes on which to measure the value of the human being. This really important question of do humans have value and how should we value them has to come from somewhere else. And very briefly, the way I like to think about it is this. It's a bit like you're walking on a dark street and there's a very bright light that shines down. And that bright light is the light of science. The great power of science is the ability to really, in this incredible tractor beam-like way, focus on certain types of problems. But there are only certain types of problems that are amenable to the scientific method. Science's great success comes precisely from self-imposed limits. And the idea that you could only find truth where the light is a little bit like a drunk looking for his keys who only looks into the light because that's the only place where he can find them. The fact is that the really important questions of life, the questions of meaning, the questions of purpose, the questions of human value, come from the shadows, if you wish. That's where we should look. There aren't kind of scientific methods that we can use to independently adjudicate for everybody where they are. But we have no choice but to go there and to look as carefully and as carefully as we can. And so my last few minutes, that's a very quick summary of a lot of ideas, I realize, so if I have questions and answers afterwards. So how would I go about then looking at adjudicating about where to ground these questions of purpose and value? I already told you that I'm a Christian. I'm an Orthodox Christian. I believe the classic creeds of the church. I think they're actually really true. And so I think that the point in all these kinds of arguments is that that the best way of going about them is the following. So the best way of looking at the evidence. The problem often with debate is not the evidence, but how to weigh the evidence. And the best way to weigh the evidence is to start from one of two possible starting points. One is that in the beginning, there's a God who created the world, and then look at the world and think, does it resonate better with that assumption, or the alternative assumption, in the beginning, nothing. Either it came out of ontological nothingness, or there's some kind of something that preceded it. And I think that starting from the assumption that there is a God makes a lot more sense of where the world is, if you ask me. I think it explains in a natural way the basis for modern science, for why we see so much beauty and fecundity in the natural world. I think it helps ground really important questions, moral questions. It grounds a kind of moral realism in a way I think is very important. I think it grounds questions of human dignity and value in ways that are absolutely critical. And I think that if I start from the assumption there is no God and then look at the world, then for me, that tapestry that it puts together, the whole, not just each part separately, is for me a lot less satisfying. I think this idea that there's a God behind the world makes the unreasonable effects of mathematics something that much more natural than if the world just popped into being out of nothing. Why would that be true? Why would we understand it? Why would the world even be mathematical? Obviously, all of these arguments are really just very generic arguments for theism. And you might think, well, that's fine, but which God should I choose? And I think that is a different question for a different time, but an incredibly important one. Because I think what you can't do is kind of sit on the fence and say, well, I don't really know, and so I'm not going to care. You have to make a choice, either one way or the other, because these questions are so important. They really matter to how we live our lives. They matter to questions of purpose and meaning. And so, just very briefly in the last minute, why do I believe particularly in Christianity? Well, there are many arguments for it. One is that, if there is a God, it would not be at all be surprising that this God would want to communicate with us. And so finding some kind of revelation is something that one might look for. And in the case of Christianity, there's the Bible, which I think is a really remarkable book. And for me, it has had an incredible impact on my life, and I think it points towards the kinds of truths that are deep and powerful. There's a resurrection of Jesus Christ, the life and teaching of Jesus Christ, which I think have exactly that kind of unexpected character, and once you find it seems something very deep and powerful. Just like when you first do look at Dirac's theorem, you think that has this completely unexpected, Dirac's derivation, unexpected, but deeply beautiful, non-intuitive, but powerful truth to it. In this way, also, I see this in the life and teachings of Jesus Christ. And of course, things like religious experience are really important. And all these things weave together into a tapestry for why I believe in Christianity, and in particular, why I'm a follower of Jesus. I've skated over a lot of things. I just want to conclude to say science and religion really, I think, are cousinly disciplines. They're open-minded searches for motivated belief. And for me, Christianity is both intellectually robust and existentially satisfying. And I'm throwing those things out there in the hope of stimulating some later conversation. And with that, I thank you very much for your attention.
It's a real great pleasure to be here tonight. Raise your hand if you are from outside of MIT. Raise your hand if you have ever been in a course of mine. Whoa, I'm so honored, particularly that after suffering through so much of my awful teaching, you're still here. So it's a real pleasure to be here tonight. and talk about our elegant universe and our role in it. And we were encouraged by the organizers to start off by putting our own cards on the table and say where we are on the religious spectrum. So I think you picked me precisely because I'm not religious and Art is. So in the way, from my point of view, it's not so much the case that the universe gives meaning to life, but rather that life gives meaning to the universe. You know, as an astrophysicist and cosmologist who spends a lot of time studying what's out there, I really feel that if there were no life in our universe at all, then if there were no self-aware collections of particles, to behold themselves and what was out there, then this would all be just a giant waste of space. And I'll come back to the ethical implications I think that has, of how important it is that we be good stewards of this fantastic gift that we are all so grateful to have. So the charge I've been giving from the organizers, as we already heard from Art, is to first talk a bit about my research and my overall worldview, and then how this makes me think about ethics and behavior in everyday life. So let's start very briefly with the research. Could we dim the lights just for a couple of minutes? I think everybody will manage to stay awake for that long. Who is the light czar? Is that possible? Turn on the lights? All right. We'll go anyway. So a bit of a cosmic perspective then. We have been thinking, we humans, about our place in the cosmos for as long as we've walked the Earth, of course, for 100,000 years or more, and gradually gotten wider and wider perspectives, realizing back in Eratosthenes' days that we're actually living in this huge spinning ball in space, which was vastly larger than people could walk around in their lives. And now, more recently, we've come to further expand our horizons and realize, back with Copernicus and onward, that we live in this beautiful solar system where it's so big that it takes lights, minutes, and hours to get from parts of it to us. We've also, of course, very actively gone out there and put a bunch of satellites in orbit around Earth, as you can see here, which has a very high MIT sort of coolness factor that we've actually been able to get off the ground here. And as we continue to look farther out into our cosmos, we've again and again realized that what we thought was everything was part of something even grander and even more elegant, very much in the spirit of the theme of tonight. So we're now moving out farther away from this classroom. So the moon's orbit is shrinking down to a little dot. We see the orbits of the planets, which Kepler so elegantly managed to capture with these mathematical equations, saying that they were ellipses. This was the solar system. This was our universe, according to the ancient Greeks, according to people in the Middle Ages. And then there were these little funky white dots that they didn't know what they were. They called stars. And it's remarkably recent that astronomers have been able to figure out that they are still vastly farther away than the planets. The typical stars you'll see tonight are hundreds of light years away. And when my grandma was about the age that many of you are now, they still didn't even know that there were other galaxies. That was only discovered in 1925 by Edwin Hubble. That actually all of this is part of something even grander, this majestic spiral-shaped object, 100,000 light years from side to side. And I've had a lot of fun here at MIT with my colleagues on this Digital Sky Survey, making a three-dimensional map of vast numbers of galaxies that you can see here. And we study the patterns in which they cluster. And by studying the intricate details of this, we learn not just about where things are in space, but also what's been happening over time. And we've gone from arguing about whether our universe is 10 billion years old to 20 billion years old to arguing about whether it's 13.7 billion years old or 13.8 billion years old. And behind all this, we see this mysterious radiation, the cosmic microwave background. Photos of the most distant thing that has ever been photographed, light that's been traveling about 13.7 billion years to get here from when our universe itself was just 400,000 years old. And in just a couple of weeks, the Planck satellite, the most ambitious space mission so far, trying to take such baby pictures, is going to release new data which will blow away these pictures in awesomeness, and you will all see this in the New York Times and elsewhere. So watch that space. So this is a fantastic expansion of our horizons that this sort of research has given us. And the question is, how has this expansion in our horizons, how has the discovery of all this grandeur affected my personal way of thinking about ethics and my day-to-day behavior? That's what I want to spend the rest of my time here talking about. In other words, when I look to the future, PowerPoint is acting up. When I look to the future, the road ahead for me and for all of humanity, what's around the corner here, if you take a cosmic perspective? It used to be that we would worry a lot about our life, what happens in the next election cycle or the next 50 years or in our lifetime. But from a cosmic perspective, I wonder a lot about what's going to happen in the next gigayear and beyond, because it's become very clear from what we've learned that the potential of life to do all these wonderful things and create more meaning in our universe is vastly, vastly greater than our ancestors ever dreamt of. So what is around the corner? There are many possibilities. There is the possibility that we can see life flourishing to fantastic new levels over billions of years. Our sun is going to fry the oceans in about 1 billion years, but if you ask me afterwards, I can tell you how we can add at least a few more billions by clever use of asteroids to move our orbit out a little bit. And we can also, if you feel it's a little crowded here in 10 to 50, there's 10 to the 57 times more volume out there where life can flourish even more. So there's a huge potential if we can get our act together. There's also a lot of so-called existential risks, or X risks for short, which have the potential of actually completely ending life as we know it. And I'm in the minority who thinks that we are actually the only planet in our observable universe that has life advanced enough to build telescopes, which means that if one of these bad things happens, the whole universe would just become completely meaningless and a waste of space. For instance, there's a possibility we could have accidental nuclear war. There have been a lot of discussions about computers being developed that are more intelligent than us humans, and one of the first things they could do very rapidly is develop still more intelligent computers, and it's in the so-called technological singularity, after which it's very hard to predict what would happen. Some people, like Ray Kurzweil, think this would be awesome, the best thing that ever happened. Other people think that this would probably destroy not just all of us humans, but also everything we ever care about. The one thing we can all agree on, I think, is that it would be a dramatic change, probably either the worst thing that ever happened or the best thing that ever happened. And you might think it's prudent in that, with such major upheavals possible to spend at least a little bit of time thinking about it. Should we worry about it? What should we do about it? Do we spend a lot of time thinking about these things? Well, this morning I saw this on CNN. Asteroid is going to come real close to Earth on Saturday, and it's going to miss. If it didn't miss, it would be a 100-megaton explosion, about twice as powerful as the most powerful hydrogen bomb ever, the famous Tsar Bomba. And the most interesting thing to me was what I highlighted in yellow in the lower right corner there, which was this was discovered last Sunday, 5 days ago. 5, okay? Way too late to actually send up a mission and deflect it, even though the technology for detecting these things and also for doing the deflections is not at all sci-fi. Here at MIT, we could totally do that sort of thing, okay? So as a professor, I instinctively always want to give grades to everybody, and those of you who have had me in their courses know that, for better or for worse. So I decided to give us humans a grade on how we've coped with existential risk so far on this Existential Risk Management 101 class, okay? I have decided, so I was thinking, well, in the standard perspective, we think of humans as the pinnacle of evolution, But in a cosmic perspective, with billions of years ahead, you ain't seen nothing yet. Now, there's so much potential for life to flourish. In terms of space, we have traditionally been very obsessed about our planet, often even about our own little personal neck of the woods. And there's 10 to the 57 times more space available in our observable universe. In terms of time, again, we obsess so much about the next election cycle and stuff like that, but there are billions of years available, so there's a huge, huge potential, okay? At the same time, as I mentioned, there's also a huge potential for really screwing up big time. Different people, some are more optimistic, some are more pessimistic. Personally, if I were betting, I would bet that there's about a 10% chance of an accidental nuclear war in my lifetime, which would really suck. I think I'm on the high side here, but I would put, for this singularity possibility, I would put it at maybe 30, 40% in my lifetime. So that doesn't mean, of course, that it is that risky, but we don't know, honestly. Maybe it's 10 to the minus 4 per decade extinction probability, maybe it's 10 to the minus 1. It would seem prudent in a situation like that to spend maybe 10 to the minus 4 of our resources, or maybe 10 to the minus 2 of our resources, kind of looking into this a little bit, taking some of you guys who are super smart and try to put at least a firm upper bound on some of these risks and say, are there some very simple measures we can do to reduce the risks? Well, I'm giving us a D- in our risk management. Why? Well, that's a question you often get as a professor after you've given it a low grade, of course. It's a good question because actually, technically, I'm not allowed to give a D- at MIT, as you know. We don't have that as a grade. But I feel so upset about what we humans are doing, squandering possibilities in the future, that I want to rub it in by putting a minus sign after the D. Why? Well, for example, the Union of Concerned Scientists is one of the biggest organizations that actually spends time looking into at least some of these X risks. They're based here in Cambridge, okay? 20 million a year, and not all of it on X risk either. If we shrink them down by 3,000 in area, they get that small, okay? Then on that same scale, this is how much money we spend on cosmetic surgery in the US each year. 10 billion, 500 times more. And this is how much we spent on air conditioning for troops in the US last year, 1,000 times more, okay? This is how much we spent on smoking in the US last year. Same scale. Spent a lot of time trying to shrink this in PowerPoint, the upper one, to make it actually fit. And of course, the elephant in the room, it doesn't even fit on my screen on this scale. In the military, we spend between 700 billion and 1.2 trillion, depending on how you count. So I have to shrink it a little bit for it to even fit. So in summary, we have a fantastic potential. We have very serious challenges. And on the upper left corner, you can see that we could maybe spend a little more of our resources thinking about this. That's why I gave it D-. So in summary, I think this cosmic perspective that being a scientist and a cosmologist has given me makes it feel so much more urgent ethically for life, for future generations, to take seriously that we should be very grateful for what we have. We don't know for sure why we have this great gift of being self-aware heaps of particles. Different people believe different things on the ontological and religious spectrum, but I think we can all agree that it's something we should be very grateful for. And we shouldn't take so lightly and be so jaded about that we take it for granted. I want to talk now a little bit more about religion. So I did a very interesting Europe project. Raise your hand if you've ever done a Europe project. It's fun to do them, isn't it? But it's also really fun to supervise them. This was one with an awesome Europe student named Eugenia Lee. I finished it off myself together with my wife, Maya, who's sitting there. We just published it for Darwin's birthday now last month on the Huffington Post. And so the bad news is something which, there's some good news and some bad news here. The bad news is something you've already read from a Gallup poll but I want to ask you first before biasing the results. Both Art and I told us about our religious views. So raise your hand if you would classify yourself as religious. Okay, I see a lot of hands. Take them down. Raise your hand if you would classify yourself as being not religious. And take them down. And raise your hand if you didn't raise your hand. Okay. Okay. Now, raise your hand if you believe that there was a big bang of some sort, maybe 14 billion years ago or so. Awesome. And raise your hand if you believe in evolution in your university. So the fact that there's such a groundswell here is very interesting because 46% of Americans do not raise their hand. 46% of all Americans believe, and contrary to you guys, that in fact humans were created less than 10,000 years ago in their present form, which would not qualify them for a job in your lab, I think. But that's the bad news. The good news, and that's what our survey was focused on, was that only 11% of Americans actually belong to a religion that takes that stance officially. And I want to just, for fun, point you to this little graphic which they put up on the Huffington Post, where you can just move your mouse over and see what different religions actually say officially. The Pentecostals here, who I thought I was very pleasantly surprised when we did this, have this nice quote here: the Bible makes no claim to be a scientific textbook, so evolution is fine, Big Bang is fine. Catholics, it's no conflict, etc., etc. And then there is, it's interesting for the ones who have a problem with this, with conflict with science, to see why. Jehovah's Witnesses say that evolution presents modern man as an improving animal, which I always thought was a good thing, and whereas they think that it's better that man is the degenerating descendant, that somehow progress goes backwards. And everybody's entitled to their opinions. It's just interesting to look at what people actually say. But the key point here is it's actually only a small minority that's colored in red who officially say that there's a conflict. Like here, for instance, the Southern Baptist Convention saying that the students are being indoctrinated in evolution science. So all of you guys who raised your hands are clearly indoctrinated. So if we look at the spectrum of views one can have on science and the science and religion issue, it goes from no religion on the left to the most extreme you can think of on the right. And what we found in our study is that the red bunch here is only 11% of all religions by membership in America have any kind of problem with science, issue with science. The vast majority is in the green region here, saying science is fine, like the great consensus in this room here at MIT. And there are two separate divides here in the science-religion debate, and I think it's very important to be aware of that and not conflate them. Some very vocal atheists, like Richard Dawkins, for example, is very focused on the left divide between no religion and religion. And interestingly, fundamentalists on the right are also trying to suggest that this is where it's at, because they want to be viewed as it being all religious people against some evil non-religious scientists who are in the minority, right? Because they know they can't win this argument if it's just them versus the rest. And I think this divide here between the anti-science and the pro-science people, that's the really important one. In my ethics that I was telling you about, I feel very strongly that we have great opportunities and face great challenges. Many of these challenges that we face involve technology, involve the kind of things we do at MIT to solve the problems. And clearly science needs to be part of that solution. Ethics and conviction and general goodness is also part of solving that. So we need a strong coalition of everybody on this side to come together and really tackle these problems. Interestingly, when we wrote this article on the Huffington Post, I had been warned in advance I was going to get a lot of hate mail. I thought I was going to get it from these guys. Well, guess where I got most of it from? From some very angry people over here who said, "You were an accommodationist, you were a disgrace for MIT," and all kind of things like this. It's like, whoa, 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 whoa. You know, I had thought that sort of the whole point of that some of these people were trying to make was you should be reasonable and listen to the other person's argument. And instead, I was accused of all kind of skullduggery, accused of saying all kind of things that I hadn't said at all, because people. So that was very interesting. And I told you what I think about religion at an intellectual level. Let me tell you also what I think about it on an emotional level, okay? I actually feel, if I think of people I know who are open-minded and tolerant, and ask how much kinship do I feel with these people, the really interesting divide is not whether they believe the same thing that I believe, but whether they are or are not interested in these big questions. That, to me, is the really, really big divide. I have some theoretical physics colleagues I respect deeply who are actually totally uninterested in big questions. Like, I don't care about that. I'm a tinkerer. I'm a mechanic. I want to do this. And I feel less kinship with that. I'm fascinated by big questions. That's why I always wanted to be a scientist when I was a kid, and that's why I'm so grateful that I get to work here at MIT and wouldn't trade my job for anything in the world. I'm passionate about these things. In my profession, disagreeing about the ontology and one's guess for what's really going on in the big picture does not in any way reduce kinship. Just as I might disagree, have different interpretations in terms of religion of what's going on in the big picture from some people I like very much, I also have very different ontological views from some non-religious people. I have some colleagues I respect greatly who believe in the Copenhagen interpretation of quantum mechanics, for example. We Swedish people love speaking ill of the Danes whenever we have an opportunity. I do not believe in the Copenhagen interpretation at all. And it's radically different in what it says about the ultimate nature of reality from what I believe. Does that mean I can't be friends with them? Ridiculous. Of course not. Does that mean that these friends of mine can't be really good citizens who bring a lot of good into the world? Of course not. So that's another reason why at an emotional level I feel that there really is nothing to get worked up at all about in terms of conflict on this side. It's only here that the real conflict lies. And I wanted to spend my last couple of minutes by asking this question. So the older I got, the more I learned about cosmology, the more insignificant I felt, because I discovered that it's just yet bigger than we thought, and yet bigger, and I felt smaller and smaller and smaller, until something remarkable happened, and I just completely transformed the way I think about this, and I wanted to share this with you. Why did I feel so insignificant? Because I felt small. I felt small in space. Here I am, just, less than 2 meters in size in this 10 to the 26 meter universe, and beyond, right? They say size isn't everything, but I mean, that's pretty small. I'm also small in time. If I eat my vitamins and do my exercise, I do bike to work, I'll maybe get to live for 100 years or something. Well, what about the 13.7 billion years of the universe? It's just like a little spark in the darkness, right? But actually, we are in an incredibly special place. We can discuss this afterwards. I'll tell you why. But I, in fact, think that we are the only planet in our entire observable universe, this entire region of space from which light has had time to reach us so far during the 13.7 billion years since the Big Bang, that has gotten to the point of having telescopes. I think we are the only ones who actually sees that stuff out there. So if we didn't exist, all those beautiful galaxies wouldn't be beautiful, because nobody would see them. They would just be a giant waste of space. And what about time? This is also a very special time. It may be, in the distant future, that life can flourish and live up to its full potential in our universe. And if so, if I'm right, that we only have this advanced life here, it started right on this planet. We're now at this amazing fork in the road where we have, within our powers, the ability to actually get our act together and create something truly awesome and beautiful, life that can really live its full potential beyond our wildest dreams. We also have within our power the ability to just end life. When is it going to be decided? I think it's going to be decided in our lifetime. I think we're at a fork in the road which is very, very unstable, but we can't just muddle along for 1,000 years and expect to still keep having all these options. I think we are now at this incredibly critical place in space and time where all of this is going to be decided. It's going to be decided by you guys. And in the distant future, if our universe is teeming with life, I don't know what our descendants will be thinking about us, but I know one thing for sure. They're not going to think, knowing that they all originated from here, that we're insignificant. So go out and seize this opportunity. Thank you. Thank you.
Well, welcome everyone. Let me add my thanks and joy to see so many people here engaging in this conversation about life, the universe, and I heard someone say 42. We're going to have a series of questions and dialogue with the speakers. I want to thank them for really wonderful presentations, both of scientific perspectives and deeply personal ones. And I'd like to add for my part that we are here as faculty members, and during the day we teach and profess about the sciences and our disciplines, but we're also human beings. And so it's an honor for us and a privilege to share that aspect of ourselves with you and to engage in these very deep and profound questions that you and many have posed. I want to start out with a question inspired by the remarks you made are about emergence, focusing from your own research into looking at systems where perhaps by evolution, perhaps by design, structure evolved with dynamics, with purpose. And the big question for me there, for you, is the emergence itself designed?
Thank you. That's a very interesting question. So if you're a Christian, then I think you naturally believe that God designed the universe. The big question, of course, is how did God do that? Did he do that by constantly twiddling at the knobs, or did he set a system in motion? Does he sustain the world in a certain way? And I think this language of emergence is a very helpful language. Just explain to you, the language of emergence, one way of thinking about emergence would be to say, if I think about water has a property of wetness. That is very different from a single water molecule, which does not have the property of wetness. So somewhere from that molecule to a lot of them together, something like wetness emerges. And so the question is that's the question that you're asking is, if we look at life, is that something that emerged? And I think that the best way for Christians to look at the way that God created the world is that he put into place emergent properties that would eventually end up with something like ourselves. I think that's a much more beautiful, much more elegant way of creating than just to make things all at once. I also think that the scriptures are consistent to some extent with both views, but I think the idea of something emerged actually goes back to St. Augustine, a great North African theologian 1,500 years ago, who talked about the potentiality being put into place at the very beginning of time. He wasn't worried about the world being, he didn't like the idea of the world being created in 6 literal days. He didn't want there to be this time period. It should all be made at once. And so I like to think of myself as a follower of St. Augustine's theology, which is essentially an emergentist perspective of how the world was created.
Thank you. Max, I want to ask a variation of that question. In your presentation, you showed how the structure, the galaxies, the life emerged, and while you described it in its spatial pattern. I know that as a cosmologist, you've studied the emergence of that structure through time.
Yes.
And while you didn't use the word emergence, what are the limits of that emergence? Can the universe and all of its structure and life have emerged? Or did there require some special set of initial conditions, whether it be a creator or something else?
Yeah, that's a fascinating question. I feel that, first and foremost, the single most important thing I feel I've learned as a scientist is how little I know and how important it is to be humble about these things. There are always things that we know, or at least think we know, and then there are things we definitely don't know. I mean, between them is this frontier. And what we humans have managed to do throughout history is gradually push the frontier of our knowledge outward in space, discovering new continents, discovering new planets, other galaxies, and as Ed Bertschinger here was alluding to, backward in time. When Newton did his fantastic work, he could figure out where the planets must have been thousands of years ago, but he had no idea where they came from. Now we have a very good idea of what happened back to 400,000 years after the beginning, because we can see that with our telescopes. And we even have a pretty good idea of what happened after the first second, because all sorts of interesting fossils have been left behind. When you do the nuclear physics, you predict there should be about 25% helium produced in the cosmic fusion reactor. In the early days, you go out and look at your telescopes, 25%. But the farther back we go, the less we know. So the first really clear answer I can give, of course, to the question of what really happened at the beginning is we don't know. There are some very interesting ideas out there. One of, so to make sure I understand specifically what you're driving at, you're wondering why things are created or started out in a way that enables us to be here? That's sort of where.
Well, there are different interpretations of the question. That would be one, and I'm happy to hear your thoughts on on that version if you're comfortable.
Yeah.
With it.
So we've realized that if you put in the initial conditions required, so that the laws of physics produce MIT 13.7 billion years later, you need to dial in a lot of things in a very, very special and surprisingly tuned way. We call this fine-tuning. We know that there are certain knobs in nature that you can dial, like how strong electromagnetism is and so on. And many of these, if you change them by just a little bit, not only wouldn't we be here, but there wouldn't even be any atoms, or there wouldn't be any galaxies, etc. And some people have taken this as evidence that our universe was in some way designed, either by a divine creator, or some people have even speculated that we are living in a computer simulation by someone who wants something interesting to happen. Another interesting possibility, which is talked about a lot, is the idea that our reality is still bigger than this universe that I kept showing on the screen. Alan Guth, our colleague here, has this theory of inflation, which predicts not only that space is really, really big, but it's probably infinitely big, and that these knobs actually might get set very differently in a sort of random way in different places. So maybe most of this vast space is actually stillborn without atoms, without galaxies, etc. And then we just find ourselves, not surprisingly, in one of the very few places where we can be, where the knobs are set just right. What's great about this is that we actually have shifted from arguing about it in bars to arguing about it in science conferences, because there are actually further predictions that can be made and things that can be tested. And I think myself, my guess is that it's the multiverse explanation, which is the right one, but we're going to get, this is going to be awesome to see the Planck data, for example, in 2 weeks, which will be the best tests of this inflation theory to date.
Art, are there limits to scientific knowledge? Are there questions that science will never address?
Yeah, so I think that there are limits, and in fact, this is a big question. There's a famous Oxford medical scientist who won the Nobel Prize, Peter Medawar, who was himself an atheist, who wrote a famous little book called The Limits of Science in 1987. Highly recommend that you read. And he said that there is a limit to science is made very likely by the kinds of questions that science can never ask. These are the questions that children ask, or he said, questions like, why am I here, and what's the purpose of life, and how should I live? And he said it's not the science, but the metaphysics and religion and imaginative literature that we should look for these things. He also said, the fact that there's a limit on science doesn't mean that somehow something is wrong with science. Rather, asking these kinds of questions of science is like asking a locomotive to fly or do something else that it was never designed for. He said it more beautifully than I say it now. And I think what he meant was this: science, limits itself to particular kinds of questions, mechanistic questions, questions of how things are. The question of is the universe significant or not is a religious question to a large extent. It cannot be answered by science. Science, it might give us some hints towards it. So the fact that the universe is very rich and fertile and beautiful suggests that it's more likely to be purposeful, perhaps. But it doesn't tell us whether it's purposeful or not. If there's nothing, I think, if there is nothing but atoms and molecules in the naturalistic world, then perhaps it's true that there is also nothing but blind, pitiless indifference. But if there is a God behind the world, then perhaps there is something of purpose beyond it. But these are questions that science can't and cannot answer. And I think so it's true that science expands all the time in what it can answer. It can help you answer things, but I think that there are fundamental limits. Let me give you one example, if you don't mind. So it's kind of a cool example, but I think it's helpful to think this through. So I would even go as far as to say that many of the most important decisions that you make in life cannot be answered by science. So let me give you an example. So who in this room is not married? All right, look around, everybody. Okay, right. Just joking. So if you, let's say you want to get married, that's an incredibly important decision that you'll make in life. And one of the questions is that amenable to the scientific methods? And also, is the alternative, therefore, irrationality? Well, the fact is, if you were to go and grab the first person that you saw raise their hand and say, marry me, that would be a truly irrational thing to do. And if the person says yes, that's even more irrational. So what you do is you get to know somebody that you like, you get to see whether you're compatible or not. You do, in fact, my wife and I, before we got married, did these kind of compatibility tests where you see whether there's things that are similar, where you squeeze a toothpaste and all those kinds of things. And we found out, for example, that neither of us has ever owned a TV, which actually turns out to be important in life, because if you're married, those are things that do matter. And that's where science can help you make that decision. But at the end of the day, you can't use the scientific methods to, for example, get scientific certainty that this is the person you ought to marry. If I'd wanted to do that, if I'd wanted to do that, I would have probably waited forever. And the reason for that is because, and you also don't do repeatable experiments in marriage, it's not a good idea. And so, it doesn't really work, does it? And one of the fundamental reasons for that is this: you don't know what it's like to be married until you've made that step. You make a step of faith. There is evidence that you cannot see until you're married. Many decisions in life have that character. There are things that you don't know about them until you're in them. So you have to take a leap of faith. You can take a rational leap of faith or a well-reasoned leap of faith, but it's always going to be a kind of leap of faith. And so I think if you insist on using the scientific methods for adjudicating whether you love somebody, if you use the hermeneutic of suspicion to say, I don't really believe this until I see evidence for it, there's evidence you'll never see. And so I think it makes you, it doesn't mean that science can't help you. These compatibility tests are helpful, but fundamentally, this kind of decision and many other decisions you make in your life are not and will never be amenable to the scientific method. And if you think that it does, then you'll be an impoverished human being. So.
Thank you.
Could I just chime in a little bit there?
Yeah, actually, Max, I was going to phrase it
Sure.
This way. Do you have the equations that might discover whether there's meaning in marriage or in life?
I have found the equation, and the answer is yes, since you're sitting right there. But I think I completely agree with you that the scientific method is not the way to go to figure out, whether you want to get chocolate ice cream or whether you prefer chocolate ice cream or strawberry ice cream, or the way to decide whether you're gay or you're straight, or what kind of music you would like to listen to. I just want to chime in that I think it's also important to not take for granted that if it's not the scientific method, it has to be religion as the only alternative way of sort of reasoning, because I think we would all agree that things like ethics, things we feel are right, they really transcend religion. And we can all think of people who we know who are religious, who are very kind people who we really admire, and people who we know are religious maybe not so nice, and then people who are not religious who are very kind, and people who are not religious and are not so nice. And so the broader question of what ethics we should have and what our goals and aspirations should be in life, I think are extremely important. And just because we don't have equations for them does not mean we shouldn't take them very seriously.
Now, Art, is that something that physicists can agree to disagree about?
So that's a good question. So I think we clearly agree that there are lots of questions outside of science, and those are not necessarily just religious questions, a wide range of questions that science can't answer. So I don't think I've ever met somebody who lives their life as if science answers all the ethical questions. I've heard people claim that, but I've never met somebody who lives their life. So I always think that if we're going to agree, I think a lot of these ethical questions, not everybody can always articulate very clearly why they take certain ethical stands. And it's important not to insist that unless somebody can articulate it philosophically very clearly, therefore they're not justified in what they do. So I would say, I have colleagues or people that sometimes make these kinds of claims. I don't think they actually, although they make these claims verbally, I don't think they really live their lives that way. So yeah. I think I would disagree with them, and I think we can agree to disagree, but I don't think if they were to really live their lives that way, then I would worry.
That's a very good point you make, and I think this forum has illustrated has brought out the two really big misconceptions that generate more heat than light in the science-religion space. On one hand, so when this spectrum I was showing, people who don't believe, people who are moderate, in my view, reasonable religious people, and then the ones I view as unreasonable, I think the universe is 6,000 years old. The most common misconception that atheists have about religious people is that all religious people believe that the universe is 6,000 years old and don't accept science, which is clearly nonsense. We saw pretty much all of you here were totally pro-science, right? So it's a terrible misconception, but it's actually widely held. A lot of the very vitriolic emails I got when I posted that thing on HuffPost were from people who assumed that I was religious, and then started accusing me of being anti-science and whatever. The other really big misconception from the other side is that some people who are religious fundamentalists assume that just because someone is not religious, they can't be ethical. And there is this very disturbing poll that you've probably seen where they ask Americans what categories of people they would never ever vote for president. So you go down, a lot of people would not vote for someone for president if they're Jewish, or if they're gay, they were even lower ranking. The lowest of all on that list were people who weren't religious. And so I think the more we can get these two twin messages out, that people aren't necessarily evil people just because they're not religious, and that people are not irrational and unscientific just because they're religious, I think the better.
So I'm hearing that you're describing a new kind of expanding universe, which has three dimensions: science, religion, and ethics.
Yes.
And you're saying that full volume is available for exploration.
Well
would you agree?
That's a nice way, interesting way of putting it. Yeah. That's a typical physicist way of thinking about it, I think. Yeah.
Here we are.
Yeah, exactly. Yeah.
I have a question from the audience for Max, for Dr. Tegmark. Why do you think that we're the only intelligent life in the universe?
Yeah, it's a minority view, first of all. So most of my colleagues disagree with me on that. My basic reasoning is this: first of all, just because we're here doesn't mean that's what happens on a typical planet, right? No matter how rare life is, we're going to find ourselves on a planet with life. So when we look more carefully at the origins of our universe, we run into a lot of things we don't understand. And as you know better than most people, when we look at the very origins of life, there are a lot of things we really have no clue whether they were very likely or very unlikely. You know, my DNA is copied with a ribosome, which is produced using DNA in turn. You know, is there some way that can evolve through a lot of very likely steps, or do you need a wild stroke of luck? You know, we really don't know. And there are many totally uncertain factors like this. So when we ask, what's the probability that intelligent life like you guys will evolve on a typical planet? The probability of P is a product of a whole bunch of numbers that we have no clue about. There could be some of them which could be super small. What we usually do in physics is we say, okay, let's say that we have a uniform probability distribution for that probability, for what the log of that probability is. It's equally likely as 10 to the minus 1, 10 to the minus 2, 10 to the minus 10, 10 to the minus 100, uniform logarithmic prior. If that's what you say, and then you work out how far are we from the nearest other planet that's as advanced as us, surprise, surprise, uniform logarithmic prior. Equally likely that it's 10 to the 20 meters, 10 to the 21 meters, 10 to the 22 meters, etc. So this huge log scale. And then we can say, okay, what do we know about actual data? Well, it seems pretty clear that there's nobody with telescopes anywhere else in our solar system. In fact, we haven't found any evidence of life yet in our galaxy. As Enrico Fermi pointed out, and we know better now, there are loads of other very habitable planets in our galaxy which formed billions of years before us. So if there were life there that evolved, they could have turned us into a parking lot by now if they wanted to. So my guess is that there's actually nothing like us anywhere in our galaxy. On this log scale, there is very little left between our galaxy, 10 to the 21, 10 to the 22 meters, and the 10 to the 26 meters. It's just 4 orders of magnitude out of many, many, many orders of magnitude. So it's much more likely, I think, that if there is life somewhere else, it's vastly farther away than the boundaries even of our universe. And so what that basically tells me is, we don't know for sure, but if there's a significant risk that if we blow it, life as a whole has blown it, that means we should really, really be careful and grateful for what we have, and not think of us as just some insignificant little civilization among so many others, and if we blow it, that's okay because the Andromedans are going to make it all be okay. No, you guys need to all go out and make a difference.
Thank you for that great perspective. And Art, in that discussion Max just gave, he was alluding to the statistical thinking of Reverend Bayes. There are also theological views on this. How would you respond to that argument?
So I'll say my ignorance. I know that theologians for quite a long history have thought about the question of other planets, and some of them have said that would be very possible, and perhaps interesting. Perhaps God could have made life on different planets. The writer C.S. Lewis from Oxford famously wrote a very interesting science fiction thing on different planets with different kinds of life on them. I think that by and large, Christianity is somewhat neutral on this idea of other planets. I don't think it really has a strong stake.
In this century.
Yeah, you mentioned stake, and Giordano Bruno ended up on one in the year 1600, exactly for saying that he thought there was life on other planets. But in fairness to the Catholic Church, they have mellowed a lot, and
they have mellowed. That's true. No, so I think the Church has done sometimes silly things, and usually if you look into more detail at what was going on in Galileo or Bruno, these were also linked to other political arguments at the time, right? So,
indeed.
So I'm afraid that's not a very satisfactory answer to your question.
What's your personal answer to it?
My personal answer is, so I kind of asked, on the one hand, I kind of hope that we find life on another planet, because that would be just really cool. Also because I am very interested, like Max said, in what is the probability that something like life that we could have the origin of life, and the only way I'm very interested in what's called convergent evolution. So the idea that if you evolve again, will you get something similar to what we have today, or if you were evolving, would you get something very different? And we only have an n of 1, which is us, and so it's hard to know. And so I'm scientifically very fascinated by the idea that there might be life somewhere else. But then I do think as a Christian, it make me think, what does that mean? Would Jesus have to die again for this other planet? I think it would raise. I think it's fair to say that it would raise some pretty serious theological thoughts. I just kind of think, wouldn't it be cool, right?
Yeah.
So that's not a very sophisticated answer. But I'd say it would be cool.
I confess I have a strong emotional hope there also, which is, on one hand, of course, I think life is fantastically cool, and so instinctively it would be nice to find more of it, even on Jupiter's moon, Europa, or so on. But actually now I'm very much crossing my fingers that all of these NASA missions will find nothing there. Mm-hmm. And the reason is because I'm very optimistic. Whenever I watch the news, I get pessimistic. Then whenever I go to class and teach you awesome people, I get optimistic about the future again. And I really hope that
So you hope that people will turn off their TV sets.
Well, and also the fact that we haven't been visited by any aliens yet, presumably, it means that life is pretty rare. Maybe I'm an alien. Actually, my wife is an alien, actually. A temporary, permanent resident, actually. But yeah, maybe life is rare. Okay, so if we know that life is rare, that means there's some kind of roadblock along the way that's very unlikely, and to the kind of life that could come and colonize us from elsewhere. There's some kind of roadblock between no life at all and then evolving all the way up to life that can colonize our universe. Where is the roadblock? Either it's behind us or it's in front of us. If we end up finding life on Mars that's evolved independently of us, which uses something other than DNA, and life on Europa, again, did it a third way, that suggests that actually getting life started is easy. And it makes me really worried that the roadblock is in front of us and that we're doomed, that we will ultimately ourselves, in our attempts to make the most of life, run into that roadblock. If it turns out that life is really, really rare, then it's more likely that the roadblock is in your department and the sort of stuff you pioneer in your lab, and something in the very early stages of life to do with a ribosome or whatnot. And that means we've already passed the roadblock, and the road is clear ahead of us, and we're only limited by our imagination. That's what I'm hoping for, and that's why I'm hoping we won't find life on Mars.
What wonderful. Art, something you said really struck me. You said that you're not sure about some of the questions, for example, whether life could have emerged elsewhere. And if it did, it might confront you with theological conundrums. What would it take? Would it be possible that some discovery would actually profoundly change your worldview?
Yes. So a simple example would be if we could find the skeleton of Jesus Christ. That would profoundly affect my worldview because I believe that Christ rose again. So if we could find in some kind of, it's hard to imagine how you would find, but let's say we would find unequivocal evidence that he died and he did not rise, that would definitely change my worldview. And I think it's important that I don't have some kind of unfalsifiable worldview. And so that's definitely something that would falsify it.
And if that happened, you wouldn't become a Jew or a Muslim, for example?
Well, okay. So I actually think that's a good question. So I think that looking at the way the world is, just the question of why is there something rather than nothing, looking at the beauty of the world very strongly suggests to me that unbalanced evidence points towards some kind of theism. I didn't give my argument, but I believe that that's why I'm a follower of Jesus Christ. So if it turns out that Jesus Christ was in fact didn't rise from the dead and I was wrong, then I would go back and say, okay, I still think these arguments about there being a God behind the world make it very likely, and I'd have to go around and see if I could find it somewhere else. So I don't say if I don't know what I would do. I'd look around, I would try my best. If you think about how would a God relate to us It's very likely that that is going to have some kind of personal elements. All kinds of things that I think are likely to be there. So I would look for something like that. It would be the saddest thing I could possibly imagine. But it's important that we're open to these kinds of possibilities. Right?
I appreciate your honesty. Thank you. Max, the same question for you. Is there anything that could profoundly change your worldview about religion?
Yes, absolutely. As I mentioned earlier, my great physics hero is Richard Feynman.
We're rubbing it in.
Once said that to him, the single most important principle of science is that you should not trust authority. And I take that to mean that we shouldn't trust any authority, including ourselves and our own prejudices. We should question everything. In fact, I find it fascinating. I'm very interested in the history of science. How many of the great discoveries were missed just because the scientist had that one preconception that he or she just wouldn't challenge. Even Einstein dropped the ball on discovering the expanding universe because he had a preconception. And so sometimes I joke that my religion is Bayesianism. And, and that means that I have to update my prior every time I get new information. If I get really, really strong evidence for something that goes against what I used to believe, then I'll change my mind. You know.
Well, there are no limits when you can keep shifting based on new discoveries. So. But it's important, what you're saying is that science is not all theoretical. We have to look to the empirical. And I'm hearing the same from you, Ard, that you would take experimental proof or disproof for religious views as being possible.
Yeah, definitely.
That's a remarkable conclusion from two theoretical physicists. I'm going to take some questions from the audience, and you have, well, I see some hands, so let's go for it. Yes.
You said that.
Is there a mic that can be
Well, we can repeat the
I
question.
should speak louder.
Good.
You described earlier. You said that you described the phenomenon of life as a gift and something we should be grateful for. And so I was curious as to what or to whom you were thinking we should be grateful.
Excellent question. So that's that's ultimate. So the question is, I said I feel very grateful. You know, I am about 100 octillion quarks and leptons. You know, I find, whoa, I'm self-aware. Whoa, how cool is this? I can ponder not only this world around me, but what I am, and it's really remarkable that it's possible for something like this to happen. And so I feel this very deep sense of gratitude, even without knowing what or exactly I'm supposed to be grateful for. And I think this is actually one of the really, this is probably the most powerful force that's driven me to want to be a scientist. The fact that I was always so fascinated about the really big questions is because I wanted to know what's really going on with this reality here. So, yeah, what is the ultimate nature of reality? That's the question that really made me want to be a physicist. I realized, of course, that to get a job at MIT and get tenure, I had to do something more concrete also. So I did, and that was also a lot of fun. But this is something that really, really drives me. And if I would have to summarize what I feel I've learned so far during the first 45 years of my life about the ultimate nature of reality, the one thing I feel really, really certain of is that whatever it is, it's very different from how it seems.
Thank you. That was a wonderful acknowledgement. Are there any Buddhists in the room? Just the question that was asked, I think, can be answered in so many ways. And one thing that both speakers have brought to light is the value of different perspectives and of humility in seeking answers about faith and meaning. So I would invite some of you to perhaps go ask friends or read about other religious perspectives on these questions, because there are a lot of views that we can all appreciate and learn from. There was a question in the back. Yes, sir.
I believe we have some questions on the iPad.
Oh, okay.
Yeah.
I should turn to the iPad.
Should get to those first. Yeah.
Are they on the screen or?
No, they're on this.
I have some here. Okay. Here's one that I really love. Is the universe actually beautiful, or do we just perceive it to be beautiful?
You know what I would say?
We've heard the answer from Max Tegmark.
So I think that's a very profound question. So I believe it is objectively beautiful, even though clearly a lot about beauty is about perception, and there are things that I find beautiful that my wife doesn't find beautiful, and vice versa, for example. So that there's definitely perception, but I think, is the universe actually beautiful in some fundamental way? I think yes. And the way I do this is by saying, well, what if the universe was, what if we had, we have this fine-tuned universe with all these constants that are just right to allow chemistry to emerge, and from that biology, and from that us. What if, what if one of the constants was tweaked so that nucleosynthesis couldn't happen, and we had just a universe made of hydrogen and helium, just a kind of gray goo of these two molecules? It would be a lot less beautiful, I think, than what we have, which is this incredibly fertile and beautiful universe. And so every time you tweak one of these fine-tuned knobs, you often get universes that I think are significantly less structured, significantly less intricate. And I think that the word beauty is the right way of, the right vector looking at that. They're significantly less beautiful. So given that there are comparable universes that are a lot less intricate and therefore less beautiful, I think that our universe is objectively beautiful. But that is that's, I think, something that I'm happy to have a longer conversation on. I might be wrong, but I think it's objectively, I think it is, I perceive it to be beautiful, but I think it is, in fact, objectively beautiful. And something like the thing I just told you about Dirac, there's something really profoundly structured and amazing about that. And in the same way that, for example, music, what makes music beautiful is partially its mathematical structure. That's part of what makes it beautiful. In the same way, that's what makes the universe beautiful.
Homework assignment. Everyone should go read Keats's Ode to a Grecian Urn.
Can I chime in on that too? Because it's
Yes.
a wonderful question. So as I mentioned earlier, my answer would be that our universe is beautiful because you are looking at it.
I thought you said you didn't believe in the Schrödinger, the Copenhagen interpretation.
But now I'm talking about the Stockholm interpretation here. More connecting with what Ard said there, not only so. The galaxy is beautiful because you see it, and that's when it gets its beauty in your eyes. And I think that's very important because Ard mentioned that complexity is to you a hallmark of beauty, mathematical regularity, and so on. And
intricacy.
And intricacy, yeah. And so it's very important to reflect on the fact that even though you have only, in quotes, 10 to the 28 particles in you, the sun has 10 to the 57 particles, you are actually vastly more complex than the sun is. And your brains, in fact, are the most complex and that's this beautiful collection of things that there is anywhere in the universe that we've discovered. The sun is just a huge blob of gas, very regular, very easy to describe. If you have a giant crystal, it's just the same sequence of atoms repeating over and over. In your DNA, you have 2 gigabytes of the ACTG molecules repeating, and they don't, but they're not periodic. There's all this information in there, and your minds are just incredibly complex, and it would be. So I think the fact that I think complexity is not merely beautiful, but I think it's also very closely related to the essence of what's so wonderful about life itself. That we are this incredibly beautiful pattern of particles moving in space-time, and if we could actually see in 4 dimensions and visualize this, I bet we would find that very beautiful as well.
Here's a question that will take advantage of your quantum mechanics expertise. This is from an audience member who wonders whether we really have to make a choice about creation. Can we be like Schrödinger's cat and both believe and doubt at the same time?
I thought that was like basically a variant of agnosticism, which is a perfectly respectable viewpoint. No? Where you have or Reverend Bayes has his priors. Do you want to elaborate on the question a little bit?
No, I think you've given a partial answer, but Art, I think that's also a question for you, because you have talked about emergence and by implication that mechanical laws are responsible for something, but perhaps not the ultimate questions.
I could just finish my answer just by being a little less Copenhagen-esque and vague there. I think believe or not believe, one has to be very clear on what one believes in, of course. So, for example, I remember having a wonderful conversation with an astronomer who worked at the Vatican Observatory, who was a priest. And that, again, felt great kinship with this man. He was obviously a devout Catholic, but he was just a wonderful guy, super knowledgeable, really interested in the big questions. So I asked him, I worked up the courage to ask him, so do you believe that God created the universe at the Planck time, 10 to the minus 43 seconds after, when we physicists have no clue what happened anyway? And I was expecting him to say yes. And he was like, oh, that's so old school. No, I don't believe that God created the universe in a temporal sense, but in a causal sense. And that reminded me of what you said, Art, when you described yourself thinking of God as having an existence outside of space and time altogether, something that transcends and exists timelessly, and maybe even just made things exist and come into being, and then let the laws of physics do their thing. How can any scientist possibly have any scientific objections to that viewpoint?
Tell us, please.
Yeah, no, amazing. Yeah. So plenty of people have had objections to that viewpoint to me. They've told me that that's an unscientific viewpoint. I disagree with the fact that it's an unscientific viewpoint, because I think it's by definition outside of science. I mean, I think these are fun things to think about. So I really like the fine-tuning arguments, because they do, on balance, I've always used them and said, on balance, they're more consistent with theism than with atheism. But then, on the other hand, I have this kind of sense, but wouldn't it be cool if there actually are more universes, right? And so I kind of balance back and forth. At least I think what it shows you is that the way our universe currently is, that we have to go somewhere beyond it if we don't believe there is a God. We need to somehow come up with some other thing like mini universes, which is interesting because it's not something that we can easily accessible to experimental evidence as a kind of a faith statement. But I was recently rereading Lewis's Narnia Chronicles, which is a children's book. In the last one, there is a kind of imagery of heaven. And then I thought, well, how is Lewis going to do this? And so he says, well, the way he thinks about it, there are these valleys, they're very beautiful, and every valley has a mountain pass to the next one, which is even more beautiful, and they keep going on forever and ever and ever. So I thought, well, why could God not make many universes? Maybe they go on forever, right? This is where I'm completely unsure about. There's no evidence of any kind, I think, that points that way, but why not?
Well, why?
Maybe I should say why. So here I think this is where I am dealing in just rank speculation.
Does this factor of 10 to the 57 that Max alluded to, the ratio between the volume of the universe and the volume of, is that the volume of the Earth?
That was the number of particles in the sun, but yeah, there are 10 to the 78 particles in our universe, so there's a lot of stuff there, yeah.
I won't try to do that math in my head. But if indeed we are special and created and contingent in a relationship with God, how do we understand such a large universe and even the possibility of infinitely many of them?
Yeah, so I think this has to do with our conception of where purpose comes from. So I think it's really important for Christians, for example, to say the reason why we have purpose is because we were created by God, not how we were created by God. It's because we were willed by God. That's where the purpose comes from. And that's something we intrinsically understand, because we say that people don't have more value before God because they're created, they're bigger or faster, have more gold fillings or whatever. And so there's something that God endows to us. And so, so given that that's the case, then a question would be, why was the universe so big? I remember the first time I went scuba diving, and I went down, and I looked around, and I was just stunned by everything I saw. And I just thought, what? Yeah, I was just like, wow. And I think to myself, human beings have not seen most of this through most of history. It's only quite recently that we could see this. Why is this the case? Well, clearly, so that's a similar question to why is the universe so big? Why is it such a beautiful why is it under the sea so incredibly beautiful? Well, I think if you read the scriptures and the way it talks about God being creative and being incredibly creative, then these things have meaning and purpose, not because I happen to see them with my goggles while I'm blowing out bubbles and trying not to breathe in the sea. They have meaning and purpose because they were created by a God who loves these kinds of things and makes things that are beautiful. And so if you read the script, when there's a very famous passage in Job. So Job was suffered tremendously, and he doesn't quite know why he suffers, and he's very angry about the suffering. He doesn't think he deserves it. And at the end, God meets him. And rather than God at the end kind of explain to him why it happened, he just says, were you there when I did this? And he describes all these things in nature. And it clearly has a kind of playful aspect to it. He talks about something that God enjoys and God likes. So given that that's the case, then why would the universe not be really big? There are all these galaxies. We didn't even know about galaxies until 1926, as Max pointed out. So if we believe that God created the world, then why would he not create it really big? Just like the same problem, why did he make all these beautiful fish under the sea? Their purpose is not for us. They weren't created just so that we could see them. They're created for something more grand. And does that make sense?
It does, I think, in a way. But what you're saying is that we cannot know the mind of God, and yet we can delight in the work, whatever we attribute that to.
That's probably better said than what I said.
Not by design, not by intelligent design, anyway. Oh, my goodness. I want to take one more question from the audience. Yes, lady here.
It's kind of a common stereotype that when religion goes searching for answers to questions, there's a certain amount of faith in order to believe the results that are found. And it's acceptable to dispute the findings. And, there are people of many different religions, and that's okay. But in science, it's commonly not accepted. You don't see too many people claiming that gravity doesn't exist or that atoms don't exist. They were
eliminated from the gene pool in unfortunate accidents.
And so I was just wondering what both of you guys thought about these stereotypes of religion and of science, and how important do you feel that within your own disciplines or within the two together to find one truth, like the existence of gravity, or are the answers to all these questions more like religion, where you just have to believe on some level?
A wonderful question. I'm going to start with Max.
Okay. So I find a striking lack of correlation between, on one hand, the religious persuasion or not that people have, and on the other hand, how willing they are to let go of their beliefs when faced with evidence. On the other hand, it's ultimately we are all evolved, to do tasks rather different, like throw rocks and eat bananas and things, rather different than what we do in our very technological world here. And it's just, some people just seem to have this mindset that they hate letting go of any ideas that they have, and they're going to stick to it come hell or high water. And you certainly see some of that when you watch some televangelists on television. But I also have some scientists, honestly, who I feel have kind of fallen in love with some particular pet theory of theirs a little bit too much. And sometimes a colleague of mine will even describe another colleague of mine by saying that, Professor so-and-so is perfectly reasonable when you discuss anything other than quantum mechanics with them or whatever. Because there's something where reason just ends, and they've made that belief part of their identity. So I think, religious or not, if we really are interested in the truth, which I think we all here really are at heart, we should all try to work on ourselves and do an epistemic spring cleaning once in a while, and try to write down, what do I really believe about different things, and do I believe it because I really thought it through myself, looked at all the evidence and said, this is what I believe, or do I believe it just because I heard my mom and dad say this when I was 5, and now I'm still believing this thing. And I think the more we are able to reflect on, be aware of what we believe and why, I think the more likely we are both to do good science and also to avoid all sorts of unnecessary problems in our relationships where we have some misconception about how other people are.
Ard, your take on this, religion and science.
So I think that's a very helpful question, this question about faith, and I think I agree with a lot of what Max said. I want to expand it in a slightly different direction to say, well, there are many important questions in life about which it's important in public discourse to allow some variation. So political views, we allow people to have different political views. We think it's important that there are different views around. Even though we might very passionately believe in our own view, we might believe ours is the right way of governing a country. Nevertheless, we recognize that there needs to be space for other views. So I think in religion it's really important that we allow that kind of public space for people to explore these things. Partially because, like that analogy I gave of the bright light, there are things that are one step out. And usually those are the really important things of life that are not necessarily that easily amenable to understand that everybody agrees on. Whereas some parts of physics, gravity, we could all agree on it, and so we can be pretty strong on gravity. But it's not the only interesting thing about the world. And so then the question is, and I think you phrase your question helpfully, because I think people often think that religion is somehow something about blind faith and science is about reason, and I think that's just the wrong way of thinking about them. They're cousinly disciplines. They're both about motivated, thoughtful, but believing in something. And the point is, at the end of the day, everybody believes something about the world. Everybody has a set of ideas about how they are. Everybody's a philosopher and everybody's a theologian. Whether they don't believe in God or they do believe in God, they are one. Right? And so you have no choice but to make those. You can't just sit around and say, I'm not going to believe things until I know them for sure. You have to make, sometimes you have to believe something and then go out and see how it works. And so back to that relational analogy I gave you about marriage. So I made a step of faith when I got married to my wife, partially because I didn't know what it was going to be like until I was married. I had hopes and dreams and aspirations, and people around me said, it sounds like a good idea, but I didn't really know. And that's because that knowledge was not accessible to me until I made a step of faith. And a lot of what a Christian would say is, a lot of our knowledge about God or our experience about God is not accessible to us until we've made a commitment of some kind to God. So I can look on the outside and think about it, just like in a marriage. I can look at the other person and think that person is going to be good. But there's knowledge I will not ever it's evidence I'll never have until I make a kind of step of faith. And so there are many of the most interesting and important questions of life have exactly that character. And so, so the idea that I should be skeptical of everything until I see evidence for it is not a healthy way of living for all these more important questions of life. You need to take a step and move forward. Otherwise, you're always sitting there waiting and looking, and you'll never get anywhere. And so that does mean that if you do take a step of faith and you say, I think this is the way the world is, I think this is what's really true, I want to leave other people some space to do their things. I might even try to convince them that I'm right, because that's a helpful way for me of testing my own ideas, and because I do think I am really right. But I have to leave them that space, right? All the things in the shadows, because I realize that because there are things I can't ever be certain about. I have to also be able to, at some point, realize that maybe I'm wrong. Right? I have to always be open to that. But that's very different. I want to point out that is what faith is about. It's reason, it's thinking about things, rethinking your faith. And it's interesting, if you look at very deeply religious people, they often will be, one of the things that Christianity does is it forces you to look really, really hard into your heart all the time and think, why am I doing what I'm doing? It's actually very exacting and difficult, and it needs real concentration to look at and think about, am I understanding this right? Have I understood this thing right about God? You're constantly thinking these kinds of things. So even if you, like me, have made a pretty firm commitment that God exists, that He revealed Himself to us in Jesus Christ, there's still many ways about what it means to be a Christian that I think it's this way and I might be wrong. And so I talk to other Christians and we think about these things, and you're constantly checking yourself. And so that is a very helpful, that is not too different from the way we do science. We also make certain commitments and then look at what the outcomes are. Right? And so there's this cousinly relationship between the two.
I want to thank you both, Ard Louis, Max Tegmark, for wonderful contributions.
Thank you. Thank you.
Thank you.
Thank you. That was fun. That was awesome. Yeah.
Thank you so much.
For more information about the Veritas Forum, including additional recordings and a calendar of upcoming events, please visit our website at veritas.org.